Chapter 33 is about energy changes in chemical reactions. In this chapter, you have to learn conservations of energy and also the definitions of exothermic and endothermic reactions. Now, please turn to the next page. Let's look at some daily examples of reactions. Now, in a cold winter, maybe you have brought this kind of hand warmer before. After you tear off the package, you take out the hand warmer gets warm. And do you know how a hand warmer works? Now actually, inside the hand warmer, it contains iron powder. You may try by using a magnet. You can see that the hand warmer is attracted towards the magnet. Now, in other words, inside the hand warmer, it contains iron powder. So, what next? After exposing the hand warmer to air, oxidation of iron occurs. In this reaction, iron 3 oxide with formula Fe2O3 is produced. This reaction is exothermic. Do you remember what is the meaning of exothermic? That is, heat is released, during the reaction. In balancing the reaction, you need to write 4 Fe here and 3 O2, so that F3 atoms on both sides are balanced. So it is the first examples of an exothermic reaction. Now I give you another example of an exothermic reaction. It is the Poisson test. Hydrogen reacts with oxygen explosively to form water. In balancing the equation, you need to add 2 in front of hydrogen gas and 2 in front of water. Because this reaction is highly exothermic, that means a lot of heat is given out. Another example, it is a thermite reaction. Thermite. 即係我嚟燒焊嚇 thermite reaction. Aluminium reacts with iron 3 oxide to form iron metal and aluminium oxide. And again, in balancing the equation, you need to put 2 in front of aluminium and 2 in front of Fe. This reaction is also exothermic. A lot of heat is given out, and the heat given out can melt our iron metal down, so that iron metal can be fused between the iron object.
Many chemical reactions are exothermic, but none quite like the thermite reaction. Here we have a piece of filter paper which we're going to fold into a cone. We're going to place a mixture of aluminum and iron oxide into the cone. We're also going to add some thermite starting mixture. This is a powdered material which helps the oxidation reaction. We're going to place that then in a hole in this container of sand. I'm then going to place a piece of magnesium ribbon down into the mixture and move the explosion shield into place before we light the magnesium fuse. Now we can take a look at the molten metal by carefully lifting it out of the sand. This white hot iron is encased in a crucible of glass that has been made by melting the sand. You can see some of the liquid metal as it dripped out of the glass. We're going to allow that to cool down, and then we'll chip some of the ceramic off the metal and take a look at it. Let's now use a hammer to crack off some of that ceramic. Here we see some of the crude ceramic that enclosed the metal. And here we see the metal, the pure iron that forms. Let's take a look at the chemical equation for this dramatic reaction. Here we see that the iron oxide is reacting with the aluminum in a single displacement reaction. The aluminum oxide is produced, and there's the iron metal that you saw in the molten state. And of course, a large amount of energy in the form of heat and light was released.
Now, let's try think about look at the first question. Do chemical reactions always give out heat? Obviously, no. Because some reactions absorb heat. I will give you the examples later. Now let's look at the second question. Can you think of any other applications which make use of chemical reactions involving energy changes? Yes, there are a lot, like self-heating coffee, okay, instant heat packs or cold pack. There are a lot of examples. Now let's look at the last question. What happens during the course of chemical reactions that involve energy changes? Now, because it involves energy changes, therefore the temperature would change. In other words, there will be a temperature change in the surrounding. Of the chemical reaction. For example, if the reaction is exothermic, the temperature in the surrounding would increase. On the contrary, if the reaction is endothermic, the temperature in the surrounding will drop. Understand? Now, what is the meaning of surrounding? Okay? And then I would like to use another term, system. Actually, the reaction can be considered as a system. And then, what is the meaning of surrounding? I need to refer to the next page. Now I would like to show you an example of a highly endothermic reaction.
What I have is some barium hydroxide. Okay, I'm going to put this into the... In fact, you know what? I'm going to do this in one of the beakers, not that big.
You may turn to page
Barium
9.
hydroxide, and I've got some ammonium chloride. Now what I'm going to do is mix these together, and hopefully we should see a endothermic reaction. Yes.
What's with the hand stuff?
What hand stuff?
The hand sanitizer gel.
Oh, it just lives on my desk.
Oh.
I was chopping up parts earlier, and yeah, I need to be not covered in blood. So, what I'm going to do to show how exothermic it is, how much heat this is taking in, so I'm going to make this wooden block wet. Okay? Now, you will see why I've done that in a second. So, I'm going to mix these two things together and carefully... Let me just break that up a bit. Mix these two things together. Well, hopefully not, because if it's blowing up and giving out huge amounts of energy like that, that would be what type of reaction? Exothermic. Now, we want to see endothermic, so it's going to be a little bit more subtle. So, I mix the barium hydroxide and the ammonium chloride together, and they should start to react.
Does it freeze it?
Well, we should soon see. So they're mixing together. Now, can you see how the consistency of that is changing slightly? It's sort of clumping together, because one of the products it's making is water in this reaction. And you can see actually that's all gone liquid, and it was all just solid powders. It's not milk, you wouldn't want to drink it. Okay, if you put that in coffee, there'll be problems. Now, one of the products of this, because it's ammonium chloride, is it's giving off ammonia, which smells rather horrible. And I'd forgotten about that, which is why I just breathed the huge load in. That sort of horrible, slightly tangy smell in wee is sort of ammonia-like.
Oh, is that what I can smell?
Yeah, that's what you can smell. Unless you've wet yourself, that is what you can smell. Okay, but also, actually, this is getting actually very cold as it's going along. Okay, now hopefully, if this has worked, it's getting cold enough. Well, you know, I put water on the base there.
Yeah.
Fingers crossed. It's actually frozen the water onto the bottom. Now, this reaction has worked so well. So much energy has had to be taken out of the environment. It's got that water so cold that it's dropped below freezing and frozen onto the bottom.
How cold
That is pretty cool.
How cold is it?
Well, I haven't got. In fact, I have got a thermometer. I'm an absolute liar. So I can put that there. That is dropping down to. Well, we know it's below what? 0. So
Freezes it 10.
this thermometer is calibrated to -10. It's shot down to -5 by about now, and it's carrying on going.
Will it freeze our fingers?
If you had it on there, yeah, it would start to. In fact, there's actually ice crystals forming on the side
Can
of the
I
room.
touch the
Ah,
side?
cool.
Cool.
Yeah. No.
Now, this is a typical example of an endothermic reaction. I would like to use this example to explain the meaning of surrounding and system. Now, the system is the reaction that is taking place inside the beaker. That is the reaction between barium hydroxide and ammonium chloride. It is the system. And during the reaction, heat is taken from the surrounding. Understand? You may turn to page 9 and look at this figure. Here, inside the beaker, we have the system. That means that the reaction between barium hydroxide and ammonium chloride. This is the system. During the reaction, because it is an endothermic reaction, so heat is taken in from the surrounding. That is the surrounding. Do you understand? Turn to page 7. Now, I would like to show you an example of an exothermic reaction, which is the displacement reaction. Zinc, being more reactive than copper metal, can displace copper metal from copper to sulfate. This is an exothermic reaction. That means if you test the temperature of the solution, this is the original temperature, 21 degrees Celsius. During the reaction, the temperature increase. That means the displacement reaction is exothermic. Now, can you tell me which one is the system and where is the surrounding? Now, you may use these pictures again to understand the relationship between system and surrounding. Inside the beaker, we have a reaction. Now is the displacement reaction. The displacement reaction can be considered as system. And during the reaction, heat is given out to the surrounding. Understand? Therefore, now turn back to page 3. Let's go through this page together. System and surroundings. When a chemical reaction takes place, there is an energy change. Okay, the energy change results in an energy transfer between the system. The system you may consider are the substance involved in the reaction and its surroundings. Surrounding is the system's environment. Here are some more examples. It is a reaction between silver ion and chloride ion. Actually, precipitate silver chloride is formed. This is an example of precipitation reaction. Now, this reaction is exothermic. Exothermic, that means heat is released. Therefore, look at this photo. In this test tube, we have silver nitrate. NaCl is added. Precipitation occurs immediately. And now, the reaction you may consider is the system. Because it is an exothermic reaction, heat is released to the surrounding. Oh, up to now, is there any problem about the definitions of system and surrounding? If no, let's move to the next part. We need to talk about the law of conservation of energy. What does it mean? Law of conservation of energy states that energy can neither be created nor destroyed. Now, please highlight this sentence first. For physics students, you have already learned this law. Law of conservation of energy. It states that energy can neither be created nor destroyed. In other words, energy must be transferred from one form to another, or from the system to the surrounding. In other words, look at this last sentence. The total amount of energy remains constant. Now, let's try class practice 33.1 together. In an experiment, hydrochloric acid was allowed to react with potassium hydroxide. Do you remember what is the name of this type of reaction? Hydrochloric acid is an acid. Potassium hydroxide is a strong alkali. In other words, neutralization reactions occur. Do you remember? Neutralization. This is the ionic equation for the neutralization reaction. In the above reaction, what substance constituted the system? Can you tell me? Now, I give you 3 seconds. 1, 2, 3. System. Now, HCl. Now, because the question asks us what, that means no need to spell. HCl, KOH, is there any others? Water. Okay, because water must be present in any solution, in aqueous solution. Finally, one more, which is the product. The product, KCl, are one of the members, okay, that constituted the system. Now, can you tell me what substances constituted the surroundings? The surroundings are water, which is the solvent. The water here is the product. Okay, I must emphasize. Water, surrounding, conical flask, air, etc. That means other than the reactants and the products in the reaction, the others are the surroundings. Do you understand? let's focus. Please, I must emphasize. Water, which is the product, is one of the member of the system. However, the water, which is the solvent, not the product, is the solvent, constitute the surroundings. Okay, so please pay attention about this point. Now, let's look at part C. States the direction of energy transfer between the system and the surroundings. As you know that neutralization is exothermic. Okay? So, energy was transferred from the system to the surroundings. Do you understand? Because it is an exothermic reaction. Therefore, energy was transferred from the system to the surrounding. What was the change in the form of energy? Change in the form. Now, look at the reaction. It involved chemical energy. Is that right? Chemical energy was changed to, can you tell me? If you use a thermometer, what is the reading in the thermometer? The temperatures increased. That means chemical energy was changed to heat energy. Understand?